probability. Equally likely outcomes, probability of an event, properties of A, and different types of example. Equally likely outcomes. In an experiment, the outcomes which have an equal chance of occurrence are called equally likely outcomes. For example, if we toss a coin, outcomes head or tail are equally likely. If we throw a dice, the outcomes 1, 2, 3, 4, 5, 6 on the top are equally likely. Now, probability of an event. The probability of an event A in a finite sample space S, written as P of A, and is defined as number of sample points in A divided by number of sample points in S. That is, probability of A is equal to N of A divided by N of S. Properties of P of A. 1. If S is the finite sample space and A is an event of S, then 0 is less than probability of A is less than 1. This probability of any event lies between 0 and 1, both inclusive. Two, probability of phi is equal to 0 and probability of sample space is equal to 1. 3. If S is the finite sample space and A is an event of S, then probability of a complement is equal to 1 minus probability of A, where A dash is the complement of A. Proof. The complement A dash of A contains those sample points of S which are not in A. N of a complement is equal to N of S minus N of A. Dividing both sides by N of S, we get probability of a complement is equal to 1 minus probability of A. Let us study probability with different examples. For example, a coin is tossed. Now find the probability of getting 1. Exactly 1 head, 2. Exactly 2 tail. Now solution. Let S be the sample space. Therefore, S is equal to HH, HT, TH, TT. N of S is equal to 4. Let A be the event of getting exactly 1 head. Then we get A is equal to HT, TH. N of A is equal to 2. Probability is equal to number of times a head comes up upon total number of times the coin is tossed. So, N of A upon N of S. Therefore, P of A is equal to 2 upon 4 comes to 1 by 2. Let B be the event of getting exactly 2 tell. Then B is equal to TT. N of B is equal to 1. Probability of B is 1 by 4. Now let us take an example related to playing cards. Student, have you seen a deck of playing cards? It consists of 52 cards which are divided into 4 suits of 13 cards each. Spades, hearts, diamonds and clubs. Clubs and spades are of black color, while hearts and diamonds are of red color. The cards in each suit are S, King, Queen, Jack, 10, 9, 8, 7, 6, 5, 4, 3 and 2. Kings, Queens and Jacks are called face cards. Let us take an example. One card is drawn from a well-shuffled deck of 52 cards. Now calculate the probability that the card will 1. Be an S, 2. Not be an S. Well shuffling ensures equally likely outcomes. There are 4 aces in the deck. Let E be the event the card is an S. The number of outcomes favorable to E is equal to 4. The number of possible outcomes is equal to 52. Therefore, number of S is equal to 52. Number of E is equal to 4. P of E is equal to number of outcomes favorable to E upon number of all possible outcomes. So, P of E is equal to 4 upon 52. Therefore, 1 upon 13. Two. Let F be the event card drawn is not an S. Card drawn is not an S means other than S. Therefore, the number of outcomes favorable to the event F is equal to 52 minus 4 comes to 48. Therefore, P of F is equal to number of outcomes favorable to F upon number of all possible outcomes is equal to 48 upon 52 comes to 12 upon 13. Let us take another example. Example is a box contains 3 blue, 2 white and 4 red marbles. If a marble is drawn at random from the box, what is the probability that it will be? White, blue or red? Solution. Saying that a marble is drawn at random means all the marbles are equally likely to be drawn. Therefore, the number of possible marbles in the box are 3 plus 2 plus 4 is equal to 9. Number of possible outcomes is equal to 9. So, N of S is equal to 9. Let W denote the event the marble is white. B denote the event the marble is blue. And R denote the event the marble is red. 1. As there are 3 blue marbles in the box, therefore the number of outcomes favorable to the event B is equal to 3. So, P of B is equal to 3 upon 9. 2. Since there are 4 red marbles in the box, therefore the number of outcomes favorable to the event R is equal to 4. So, P of R is equal to 4 by 9. Note that probability of W plus probability of B plus probability of R is equal to 2 upon 9 plus 3 upon 9 plus 4 upon 9. So 2 plus 3 plus 4 upon 9 comes to 9 upon 9 and is equal to 1. So probability of W plus probability of B plus probability of R is equal 1. Let us take one more example. 2 dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of the dice is 1, 8, 2, 13, 3 less than or equal to 12? Now the solution is, when the blue dice shows 1, the grey dice could show any one of the numbers 1, 2, 3, 4, 5, 6. The same is true when the blue dice shows 2, 3, 4, 5 or 6. The possible outcomes of the experiment are listed in the table. The first number in each order pair is the number appearing on the blue dice, and the second number is that on the grey dice. So the number of possible outcomes is equal to 6 into 6. So N of S is equal to 36. The outcomes favorable to the event, the sum of the two numbers is 8, denoted E. Are checked the highlight diagonal part in table. The sum of each outcome is 8. That is 2 plus 6 is equal to 8. 3 plus 5 is equal to 8. 4 plus 4 is also equal to 8. 5 plus 3 is equal to 8. And 6 plus 2 is equal to 8. The highest sum of the outcome is 6 plus 6 is equal to 12. As you can see from table, there is no outcome favorable to the event F. The sum of two numbers is 13. So, probability of F is equal to 0 upon 36. So, P of F is equal to 0. As shown in the table, all the outcomes has the sum less than or equal to 12. Therefore, all the outcomes are favorable to the event G. Sum of two numbers less than or equal to 12. So, probability G is equal to 36 upon 36. So, P of G is equal to 1. Addition theorem of probability. There are 10 number cards on which numbers 1 to 10 are written separately, and a card is drawn at random. Let's be the sample space having numbers 1 to 10. Therefore, number of S is equal to 10. Let A be the event of getting a card where the number on the card is a multiple of 2. Therefore, set A be the event having numbers 2, 4, 6, 8, 10. Number of A is equal to 5. Therefore, probability of A is equal to number of sample points in event A upon number of sample points in S is equal to 5 by 10. Let B be the event of getting a card where the number on the card is a multiple of 3. Therefore, set B be the event having numbers 3, 6, 9. Number of B is equal to 3. Therefore, probability of B is equal to number of sample points in event B upon number of sample points in S is equal to 3 by 10. Now, A union B is the set of numbers 2, 3, 4, 6, 8, 9, 10. So, number of A union B is 7. Probability of A union B is equal to number of sample points in event A union B upon number of sample points in S and is equal to 7 by 10. A intersection B is the set of numbers 6. So, number of A intersection B is 1. Probability of A intersection B is equal to number of sample points in event A intersection B upon number of sample points in S is equal to 1 by 10. Here, 5 by 10 plus 3 by 10 is same as 7 by 10 plus 1 by 10. Therefore, we get probability of A plus probability of B is equal to probability of A union B plus probability of A intersection B. If we want to form the whole equation in probability of A union B, for that we transform probability of A intersection B in left-hand side. Therefore, we get probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. If A and B are any two events of a sample space S, then probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B is an addition theorem of probability. Summary. In this subtopic, we learned how we get equally likely outcomes, probability of an event, properties of A, and different types of example. So that is all in this subtopic, student. Till then, keep learning. Bye.